Okay, let's start talk about example of amoeba detection. And you'll need to install a Jetson inference project from GitHub, from their Jetson inference GitHub, before we can do this example. So you'll need to go back for installing. We'll need to go back to here. There's a note. So if you just get a new Jetson Nano device, you will need to take time to boot the Jetson device and install the Jetson Inference project on it. So for the booting, the tutorials are provided in the NVIDIA website. You can just follow the tutorials and boot your Jetson Nano and install the Linux operating system on it. Okay. So here is the booting. And for the Jetson Inference project, so there is a source in here. Here is the original GitHub project for the Jetson Inference. So you just type or just copy paste this command line in your local Jetson Nano, and it will directly install the Jetson Inference into your local Jetson Nano. So you will got a Jetson Inference folder after doing that. There is also another great YouTube tutorials. You can just hit this link and watch that videos to see the details of it. Okay, and after doing that, you can just go ahead and run this example. Again, if you have any questions, you can just upload to my GitHub and to ask. So first, you will need to load the images dataset to the correct directory. So we just copy and paste the first command line. So this will change the directory to the directory of SSD. So right now we are in the directory of SSD. So we can find out the directory in our window. Okay, detection SSD. So right now actually we are in the directory of this. And then what we'll do is git clone our amoeba detection project from our amoeba detection GitHub. So you just copy paste this line. So it will start to download amoeba detection project into the current directory. The current directory is SSD. So in order to run this code, we'll need to make sure there is internet is connected. If you have any questions doing that, again, just go to this my GitHub to upload in your question. Okay, and then we can click enter, and it will start. And you will see a folder called amoeba detection created in the current directory. Okay, let's start training the model. Before training, make sure the current directory is under Jetson Nano SSD. And what we'll do is just to copy this line and paste it in your command line. So what does this line mean? So first, the Python 3. If you installed Python 3, so you can use this command line. And then there's a train ssd.py is corresponding to that train ssd.py. And then you will give it several arguments. So the first argument is data. So the data, it means the dataset directory. We need to locate the amoeba dataset in our GitHub project. So this is just the directory of our dataset. So you can locate it, find out dataset section 3, and then go to amoeba dataset, and then training dataset. Here is what our dataset allocate. You can just look at what does it looks for the images, and you also have the annotation files and labels. Okay, that is the dataset, and then you have the model directory. What it means is after training, you got models, epoch models. So these tell us where we should save our model. And it was saved in the models. And then you can click the models. So it was saved in here. And after a training, it'll create a folder called Amoeba model MB2. So it will save all of the train model checkpoints to that location. Another one is the dataset type is VUC. If you use .xml file format, you just you write VUC and the net. So the net is MB2 SSD Lite. We have got several network architecture. You can use MB1 SSD, MB1 Lite SSD, and MB2 SSD Lite. So you can use different network. The performance will be different. So this argument of net, and then you have the pre-trained SSD. So it's used the pre-trained models. It's like the backbones in the SSD. And then it's the epoch. We will use the epoch 20. If you want to repeat the exact same results with me published in the GitHub, you can set this epoch number to 60. But to save our time, 20 will be good enough. Yeah, now here is all the argument we will use. And we can click enter. Oh, there's some errors because we have a $sign in the end, at the beginning. So you can just go back, delete that $sign. And then I hit enter again. Now it'll start to train this model. Okay, this is a good sign, means that it start to train. It will take a lot of time and also use a lot of memories in the Jetson Nano. So we can close the windows, gives more memory to this training process. Okay, the training process is done, and it exits the program. And we have the total of 20 epoch. You will see some informations printed in the command line windows. And the whole process takes about 15 minutes. And now what we will do next is convert the model to ONNX. It means Open Neural Network Exchange. Just copy this line, the Python 3, and we copied it, paste it. Now, this ONNX export is corresponding to these files, and it will save the ONNX model to that directory. The network we use is the same with in the training process, and we hit enter. Okay, it will start to converting, and find out the best checkpoint during this process. Okay. Yeah, this this folder contains all of our 20 epoch trained models. Okay, our best checkpoint is number epoch 19. You will see it from here. And then after converting, so the model exported in this folder. So next, we will evaluate our model by running this code. So we just copy and paste in here. And we'll need to change the trained model checkpoints to the epoch 19 in here. And we use the tab, and this is 19, and hit tab again, so it will fill out automatically. We find out the best checkpoints and hit enter. It will start running and evaluate our trained model. Okay, and you can ignore these warnings. It's all good. So this process, you will see it will evaluate our test dataset, and now it generates the prediction time and finally give us the average precision per class and average precision across all classes. Since we just contain one class, so it will be the same with the previous number. So we got the performance. Here is the evaluation of our trained model. And then we'll run the inference. So first we can run the inference for our test data set. So we just copy and paste in here. So this line is just a cd our directory to the test dataset inference, and in there you can just use ls to list all the files in the test dataset inference folder. You will see you have a predict image and a test dataset, and then we will run that Python files predict images, but just use python3 predict images.py. And now after hit enter, it will start to process our trained model, and then it will start to run the inference. So actually we can see where our inference locate. Click test dataset, and so what we're doing is to find out the test dataset inference folder. So what does it contain? So after this process finished, you will see our predicted image will created in this folder, and that predicted image will contains the bounding box and the corresponding confidence about that. So this process is still running. After it finishes, we can check our results in the current folder. Okay, so after this inference process finished, you will see that we generated some predicted image in the folder. Right? This is a very great sign. Click one, and you will see that the corresponding bounding boxes and also the confidence. And this is a very good sign. And of course, you can also run the same process for the drop one inference by changing your location to the drop one inference folder. I think that's it.